MrBond is actually doing live camps. But I'm staying in here, and I've made that very clear. So we're gonna stay safe and be here. Does anybody have a clue, any idea what we're doing today? Did you guys get in on this? What was it?
Experiment.
An experiment. We're definitely doing hands-on experiment. We're gonna do hands-on experiment that if you can take notes, or do you all have materials at home for this?
Yes. No.
You've been
No.
told
Not right now.
Some of them was able to pick up kits, some of them wasn't.
Here's what's cool. Every experiment we're going to do, you can do at home with one serious exception that you can still do at home. It just requires finding some special materials. And we'll talk about why that last one that we're going to do is not really one that you want to do at home, to be honest with you. We'll talk about that. All right, so I'm Professor Graybeard. Everybody, can you say, what's up, Professor Graybeard?
What's up, Professor Graybeard?
What's up is obviously science, right? I'm here to do science experiments with you. I don't have any rules in this particular situation other than what I already see. You guys are perfect with this. You've been doing this. You've been probably following all the steps when you're doing Zoom. I don't have to remind you about Zoom behavior. You guys are way ahead of me on it, so I'm not going to even bother you with that. You may find me actually talking in the corner, looking in weird places. Most of the time it's because I'm by myself and I'm checking the technology stuff, but I'm going to try to talk to you all right? If I don't do it very well, don't hesitate. I've actually thought about cutting out a head and stick it on the back of the camera so that I actually am looking at a person, because I'm used to looking at your faces in the corner. I don't know if you all do that, but when you're talking to someone, you're looking at their face, because that's what we, as human beings, we like to look into eyes. Well, unless we're being yelled at, and then we look down. All right, we're going to be doing some chemical reactions. Right? Does anybody know what a chemical reaction is? Anybody know the definition of a chemical reaction? So you're going to go back to multi-view. I want to see everybody's faces as we're talking. Multi-view. All right, show. All right, I'm changing mine. All right, good. I don't like to look at myself. I want to look at y'all. Coach Hayes, how come I don't see any other beautiful faces on here? Are we all hiding our faces?
Can everybody go on the screen?
It's the perfect time to get
possible.
Yeah, I gotcha. I would like to see your faces, but okay.
Middle
so
school.
We're going to be doing a number of chemical reactions. Every one of these chemical reactions have produced something. They take one thing, and we know when we do a chemical reaction, we are actually changing something from one thing to another. On a small scale, we might get a little bit of heat, or it might get cold. And on a larger scale, sometimes we get mega amounts of heat. And in some cases, we actually get super cooling. All right. So a phase shift occurs. And we all know the 3 states of matter, right, guys? We know the 3 states. There's actually 4. Well, actually, there's 5. Well, now they're working on 6. Actually, they're past 6. They're going to 7. Actually, they're going nuts. But the 3 primary states of matter are solids, liquids, and gases, right? And anytime we move from a solid to a liquid to a gas, that's a phase shift. But if we jump from one all the way past one to another, we get an even larger phase shift. Every phase shift produces energy. And this is what we're going to do. Our first phase shift is one you can do at home. You guys know what this is? Seen one of these before?
Yes, we did it.
It's called banana.
What's it called? What's the thing called?
What?
What did it start with?
It's a film canister. In the olden days, when I was your age, we didn't have digital cameras. Well, actually, we were just getting digital cameras, and they're very expensive. And instead, we recorded on a film or it's just a little piece of, I can't even remember what it was made of. Coach, do you remember what it's made of?
I don't remember exactly what it was made of, but I remember the material that came out of the actual roll. Yeah, the film cartridge.
You could hold them up to the light and everybody was reversed.
Yeah.
Everybody was backward. So Where things were light, they were dark, and where they were dark, they were light. This is called a negative. Anyway, old school. Used to stick film in it. Now I call them film canisters because I can fill them with anything I want. And what I'm going to fill this with is this. Everybody knows what this is, right? Yeah.
Yeah.
Everybody say H2O. H2O is going to be our catalyst for this experiment.
Water.
Now, if you've ever seen us come and do experiments with you, a lot of times we bring dry ice, right? But in this case, I'm going to do the same experiment we've done with you guys for something you can get at the Dollar Tree. You can get this at Kroger. This is an antacid tablet. Now, this is a brand called Alka-Seltzer, but you can get stuff at Kroger for like half the price. This is a secret tablet filled with, this is for your stomach. If you have an upset stomach, you eat too much pizza, it's a great way to make you go brrr and get rid of all that gas that builds up. But it actually has some secret ingredients. We'll talk about what those ingredients are in just a second. Now, I'm going to drop this in here. And then, just to make sure it doesn't spill, I'm going to go ahead and put this on. Now, I put the cap on. Sorry. I put the cap on to contain the material. I turn it upside down. It doesn't spill out, right? But actually, I don't want to turn it upside down because I don't have anything to launch it from. But I could possibly, uh-oh. I think I broke it. Would it be a good idea to look at the canister and see what's going on here? Look and see why it's not coming out of there? Obviously not, because it's building up a whole bunch of pressure. Everybody say pressure.
Correct.
Pressure is a product of this reaction. Now, probably what's happening now, and the reason the cap isn't popping off the second time,
It's dissolving.
the what now?
It's dissolving.
It's dissolving, right? But I am getting the fizzy still coming out of there. For some reason, the cap's not flying off because I think I've actually got some grit. It's not letting it seal properly. So now it's coming out the sides, which is always a little disappointing. But let's try this one. Now, this is pretty simple. If you're doing this at home and you can't find a film canister, there is an alternative. And that alternative is called a Milo tea bottle. Anybody here drink Milo tea?
No.
I do.
Here's what you're looking for.
Good
You're
tea.
looking for the snap-on cap that goes on a giant milk jug, not the screw-on cap. Don't use screw-on caps. Dangerous. And after the 4th of July, I mean, you all know. Anybody get burned on the 4th?
No.
I didn't even leave my house. I sat in my backyard and watched all the explosions in my neighborhood. Put another tablet in there. I don't think. Oh! Okay, it worked again. All right. So we are doing a chemical reaction. We're using the water as a catalyst. Within the tablet, there are two materials. One of those materials is citric acid, powdered citric acid. Now, you can go to the store and you can buy powdered citric acid in this form. Y'all ever seen this before? This is,
What is
sorry, I took off my autofocus because it drives me nuts, but you know, that's why I did the close-up. Hold on. Close-up camera. Brand is called True Lemon. Can you see it?
Is that tea?
Yes.
Actually just lemon juice. It's dried lemon juice. So this is concentrated citric acid. So concentrated citric acid. So one of these tablets actually contains the same type of thing, a concentrated citric acid. I don't know where they get their citric acid in these cases, but within this tablet, there's a binder that holds it together, citric acid, and something else. That something else is in this box.
Oh, baking soda.
Soda. So here's what these two have that make them react the way they react. One is an acid, and the other one is a base. And you all know it's all about that base. But, okay, sorry, it was terrible. You know why I go there. I just embarrassed myself. All right. So baking soda and lemon juice in a powder. So tell you what, let's just try to make one of these. Now we can't bind it. We don't have a binder. So we're gonna go ahead and take this. I'm gonna empty all this out of here in my cup here. And you may be able to see, but I'm gonna pour that into the bottom. It's in there. And then I'm gonna add this. No, not that. I'm gonna add some baking soda. That would have been crazy to do that. All right, it's in this cup so I can get to it. I think we'll do it just a scoop, about that much. Don't worry, you're not doing this one, but you can do this. And we're gonna try this. Let's see what we get, what kind of reaction we get. Because I don't know if this canisters are particularly reliable. But those Milo tea bottles with the snap-on cap gives you the same reaction. Unfortunately, though, you're going to have to use twice as many tablets unless you got something like this going on. Let's see if we can do this. Are we getting the same type of reaction? Well, it is bubbling. Oh, come on. Be cooperative. Huh. I know it's bubbling. Let me show you at least that it's bubbling so you'll believe me. Change into the close-up. See how it's bubbling in there?
Yes,
Yeah.
it's dissolving.
Carbon dioxide. And that's what this chemical reaction does. This chemical reaction transforms the two materials, the powdered lemon juice and the baking soda, an acid and a base, also known as alkaline. When they mix, their product or what they produce is carbon dioxide. So it's a pretty basic experiment. You guys can do this one pretty easily at home, but let's see if we can just do it with a different material. We're going to use this. And you're going to hear me talk. I'm going to switch back to the close-up. I wish I had OBS going here, Broadcast Studio, because then you can see what I'm doing and also see my face as I'm talking. Can you all see this? All right. So what we're going to do is we're going to take some of these materials. We're going to take some of this stuff, which is water. And then we're going to take some of that baking soda again. Actually, you know what? We don't need water. Let's get crazy. I'm instead going to use some of what's in this cup. See this? This is something you got home. I guarantee it. It's called vinegar. Can you see it?
Yes.
It looks like water, but if you were here to smell it, you'd know. And when we smell stuff, we do this. Waft it. Make sure we do that safely. So I'm going to add this to here. Yeah, you know what? Let's just get crazy. I want you to see what's happening. Can you see that clearly?
Yep.
All right. And then I'm going to add, let's see, some of this. See that okay?
Yes, that's my favorite color.
Why did I add blue, guys? Yeah? Why did I add blue? Because it looks nice. Let's do it the
That's
experiment.
what I was gonna say.
Because it looks nice. There is no chemical reaction. I'm keep getting a little nervous about it. There you go. Now you can see it. Excellent. Now I'm going to add, tell you what, something else you can get from the store. This is Ninja Fluid. Anybody been to Ninja Fluid? Anybody been to the store
What
lately?
is that?
Yeah. Oh, I'm sorry. It's known as dishwashing liquid. I got some of it.
I was confused.
Dollar Tree cheap stuff, right? So you can do this for about $3, I think, at the Dollar Tree. Okay, so where's my baking soda cup? I just have, here it is. All right, so I've added a little bit of soap. Why did I add soap?
It explode.
So
Bubbles.
I want to contain the explosion in bubbles. so we can actually see what happens. Otherwise, we just see it fizz. If I add bubbles, let's see what happens. Okay, I'm going to do, what do you think? A whole scoop? It's like about three of those tablets. All right, here we go. So like I said, this is one you can do at home. It's alive! This is carbon dioxide expanding into the air. This is elephant toothpaste. But this is super simple elephant toothpaste. This is elephant toothpaste that you can do with cheap stuff from the grocery store.
Yeah.
I think
Oh, Professor Graybird, I have a question.
yes, ma'am.
If you don't mind, can you because if that's the safe one to do at home, right?
That's one you can do at home.
Can you I'm about to say, can you tell me the ingredients again? That way I can put them in the chat, or can you put them in the chat?
Absolutely. Let's do that. Baking soda.
Baking soda.
Which
Feel
is,
free to take notes if y'all want to, y'all, because this is simple stuff you can find at home more than
bicarbonate of soda, but it's baking soda. Just get a box of this, and then this is at the Dollar Tree for like two boxes for $1.
yeah, it's like 50 cents. And what else?
I used was good old-fashioned vinegar. Now, as I always have vinegar for cleaning, I use vinegar for a lot of things, so I've always got a bottle of vinegar. There's a lot of different types of vinegar, apple cider vinegar. It's a couple different types. So easy to find. The next thing I have,
Baking soda, vinegar, and oh, okay.
washing liquid. These are the things that you definitely need to get the foamy stuff.
Okay, cool.
And the last thing, of course, if you have it laying around, is some color.
Okay.
It's pretty
Thank
basic. Should we make it a little more chemical, little crazier?
Yes.
Yes.
By the way, I forgot to mention, for the exploding canisters, you need an antacid tablet.
Okay.
But I think we should make this a little more fancy than this, because I'm going to move this out of the way. I think we're going to go with some more dangerous chemicals. All right. This is hydrogen peroxide, H2O2. Anybody tell me something that you recognize that's similar to this? H2O2, what's similar to this stuff? Anybody know?
The tab.
Anybody know?
Water.
O2, what was that?
H2O. Water. H2O.
Water. Now here's the deal. This I can drink.
That.
I don't really want to drink. This I can drink at this particular level, but it will make me feel really bad and probably make me throw up.
That happened to me once when I was little.
Yeah, you get a glass of this, and unless it's to make, sometimes you use this as what's called a, I can't remember. I forgot the word. It's
You
like
can gargle with it.
Yeah, you can rinse your mouth out with this, because this will clean, like if you got in trouble with your teeth, like I have a tooth way in the back that I have trouble with. Sometimes I gargle with this to get that tooth clean back there and bubble out things. If you've got a cut, if you put this on your cut, it will surface clean and bubble out any debris in there. If you have a deep cut, please do not use this on deep cuts.
Okay.
This is not an antiseptic. You need something like alcohol, because this destroys cells. And it destroys all living cells by causing them to explode. So if there are people out there that are telling, hey, buy this stuff, dilute it and drink it, it'll help you fight cancer. Well, yeah, I mean, it will get rid of cancer cells, but it also kills all the other cells along with it. That's not a good way to defeat cancer. To defeat cancer, you have to be targeted to get rid of the cancer cells without killing all the other important cells in our body. So don't drink this stuff, and don't listen to those crazy people say, oh, it's a secret cure for getting rid of, because some health stores actually sell this. We'll talk about that in a minute. But yeah, by the way, this is the product of putting hydrogen peroxide on a cut and not knowing any better. See how crooked my finger is? Yeah, I should have gone to a doctor too, and I didn't. So, hydrogen peroxide. H2O2, it has an extra oxygen. We want to break that oxygen free. We want to get it out of there. We want to do a chemical reaction where we phase shift the materials from H2O2 into H2O and oxygen. So we want to break off that extra oxygen. 3% hydrogen peroxide. Now, guys, if this is only 3%, what do you think the other 95% in here is? What's this mixed with to take up the other
Liquid.
95%? Anybody have a hypothesis?
Water.
Huh?
What was it?
Water.
Yeah, mixes well with water. Exactly. So water is the other material. So I'm going to go ahead and open this. Now, normally we use this without gloves, but I'm going to get my gloves on so I don't forget to put them on when it gets even more dangerous, all right? All right, have that upside down. I'm trying to put my pinky in the thumb. These you can also pick up at the Dollar Tree. You can get the cleaning ones. It's always good when you do chemical reactions to wear gloves if you can get them, plus they make you feel super sciencey, which I always like wearing gloves. And I like having blue hands. All right, so I got my blue gloves on, and I'm actually gonna put on my safety glasses. For this one, we don't have to worry that much about it because it's only 3% hydrogen peroxide. In fact, I got a brand new bottle here that I need to open up. All right. I'm actually going to try to use another bottle here. Got so many up on my shelf, I think I'm going to grab this guy. We'll use another Erlenmeyer flask. Put him there. Now here's what else we're going to need to get from this grocery store. You can get these in little packets like the antacid, or you can buy it in a jar. This is not totally cheap right now. Seems like everybody at home is baking bread. This is yeast. This is actually a lie. This is a living organism that has been dehydrated, so it's gone dormant. As soon as you add water to this, it actually is alive. It is a microbe that we use to make bread. Anybody else want to know? What else do we make with yeast? Anybody have any ideas?
Water.
What else do we make?
Pizza. Pizza.
Pizza, exactly. Make that pizza crust fluffy so it's not just like a tortilla. We also make beer, wine. So homemade wine and beer. Anything that you make yeast, add yeast to, will cause it to ferment or change. It breaks sugar down. It likes to eat. In this case,
Donuts.
We learned about that in 7th grade.
cake donuts, exactly. All right, so I'm going to take this and I'm going to put it into a beaker. And I'm right now very crystal. See, if you smell it, it kind of smells like pizza dough. I'm going to add some
water.
No, that's a little cold. Let me get some room temperature water. Warm to room temperature water is your best bet. If it's too hot, guess what happens to the yeast, my friends, if the water's too low? Someone's an explosion, aren't they?
Wouldn't it kill it? Like kill it? It kills the yeast?
It boils it. It kills it. When you make bread, you do not want super hot water. So I'm gonna mix this up, and as soon as it gets wet, you can start smelling it. I actually think yeast reminds me a little bit of the smell of corn. And the reason is corn actually has a yeast reaction within it as well. So, ooh, it's getting, look. It's clumping up, getting a bit clumpy. This means the water wasn't quite warm enough, but it'll be fine. Now what I'm doing is I'm activating the yeast. It's coming alive. It looks for something it wants to eat. So what it's looking for, yeast is looking for oxygen. Now what does my H2O2 have an extra one of?
You said water.
Yeah, what's water? H.
2O.
Oh,
What is hydrogen peroxide? It's H. 2O.
2.
It has an extra oxygen. If we can rip it off, we can convert hydrogen peroxide into water. And this is actually an exothermic reaction, which means it produces energy in the form of heat energy. So let's see if we can do this one. All right, we're going to keep this, let this mix, keep mixing here. We're going to take some of this hydrogen peroxide and pour it into, that's quite a bit, maybe a bit too much, but pour that into my,
you put it closer.
yes, let's go closer. How's that? Can you see it now?
Yeah, that's
All
good.
right. What color should we add this time? Coach Hayes, thumbs up. What do you think, Alex? Should we do purple?
What color, y'all?
Red.
Green.
All right.
Somebody said red first.
All right, so you can see this well. Here we go. A little red. So what we've done is we've taken Flashman's yeast and we've added a little warm water and we've mixed it up into a paste. And we're going to set this aside. So there's the paste. All right. And now what we've done is we've taken our hydrogen peroxide and we put it in a chosen bottle. That bottle, or you can also use this kind of bottle, guys. Simple water bottle. You know what? So you don't have these at home, you have this at home. Okay, now, what's the other ingredient you think I need to add to this? I'm gonna make elephant toothpaste. What should I add to this?
Peroxide.
Peroxide, okay, so that's what we've got. We've got our peroxide. What else can we add? We've added color. What else can we add now to make this interesting to look at?
Water.
Water? No, I don't want to dilute it. We want to make water.
Dishwater.
Dishwashing liquid, let's do that. Why do we add dishwashing liquid?
So it bubbles.
Bubbles.
Make bubbles! All right, here we go. Let's hope I got the correct proportions. All right, I think we're ready. You guys ready for this?
Yes.
Everybody, y'all set? Here we go. I'm gonna count down. 3,
Uh-oh. 3,
2,
2,
1,
1.
0.
Are you ready? Go! Bigger!
That's cool. It's all foamy.
It was faster than the other one.
That was much faster, wasn't it? If you were here, you could put your hand over it and kind of feel a little bit of heat. This is, again, an exothermic reaction. What is happening right now is we're converting the H2O2 into H2O and oxygen. So before we did CO2, now we're doing simple oxygen reaction. It's a pretty pink. Did you guys plan the pink? Did you expect that red to get that pink? How can we make that redder, my friends? I want it to be dark, more red. What could I do to it?
Add more food coloring.
Thank you so much. Exactly. Add more food coloring.
Blue, red, purple.
Add more food coloring. All right, now, who's ready to do some classroom or high school science?
Me.
This means we're going to get a little more dangerous. This is why I actually have my glasses and my gloves on, because instead of using 3% hydrogen peroxide, the remaining 97% being water, we're going to get a little more dangerous. we're going to go with this stuff. This is essentially rocket fuel. All right. This is 34% hydrogen peroxide. 34%. In fact, during the early rocket experiments in American history, Werner von Braun and those guys, they basically used this as rocket fuel for some of their test rockets. Now, this is not controllable. Once you start the reaction, you can't stop the reaction. So it's fine if you're going to launch something, but you definitely can't control it and make sure anything is taken where it needs to go. Yeah. Oh, but also, this is sold for cleaning in your schools.
Does that make water?
Yeah, they add it to their water in the sink in your cafeteria. This is a good way to kill certain bacteria by breaking apart its cells, by exploding the cells. And it's a good way to keep you all safe. They're probably going to use this and continue to use this for your schools. But for us, it means that we get a bigger reaction, right? Bigger.
I have a question.
Yes, ma'am.
Percentage-wise, what's the difference between the regular peroxide and the stronger peroxide? What's the
This is only 3% hydrogen peroxide with the remaining 97% water. This is 34% hydrogen peroxide with the remaining amount or suspension material is water at 66%. Is my math good there? Yeah, 60%.
Cool.
Now, other material, I cannot use our store-bought stuff. I can't use this stuff, right? The yeast will die. If I add this to the yeast can't react quickly enough before they explode. This will neutralize the yeast. If I need something that's inert, everybody say inert? Inert. The inert means it's not alive. Inert means that this is a salt. This is a mineral. This is called potassium iodide. And it's a crystal that looks a lot like salt. Can you see that?
Mm-hmm.
Potassium iodide is radioactive. It is actually used to make your body flush out radiation. And in fact, in certain parts of the world right now, people are taking this on a daily basis. Near Chernobyl in the Ukraine, they take this on a daily basis and have been doing it for over 40 years because they had a nuclear meltdown and that area still has radiation in the area. So people take this daily to make sure that their body will react to flush out radiation. In a place called Fukushima, Japan, in the Daiichi Prefecture, north of Tokyo, there was a meltdown of a nuclear reactor. This was due to a tsunami. This happened maybe 7, 8, 10 years ago now, I think. And when this happened, I think it was 2011. So, yeah, 9 years ago. They have to take this, but it's not dangerous to us. Here's what we're going to do. We're going to mix this up. What should I mix this with, guys? What would be a good material to break down this salt? What could you add to regular salt at home to make your salt break down? Or sugar?
Water.
Water.
I'm going to add water just so I can pour this. And you know what? Can we get a little crazy? Just a tiny bit crazy? Here we go. We're going to get a little bit crazy because I was thinking you all would appreciate this. I don't normally do it this way, but I want to show you just how careful we have to be. I don't want to use some of these bottles. Let's see if this one will work. I'm going to use this one again. I'm going to rinse this out. All right. I'm going to put a little bit of my hydrogen peroxide, 34%. I shouldn't get any reaction yet. All right. I'm going to get close up to the container there. All right. And I'm only going to put a tiny bit of this in here. I've got my safety glasses on. Oh, that's not going to work. There's a hole in it. All right. So I'm not putting a whole lot in here. Can you see in the bottom there? Barely see it. It's pretty white. I'm going to drop it in here. Y'all watch this. Can you all see the container pretty well?
Yeah.
Okay. You can, or should I zoom in closer? Actually, I can get closer. Let's make this exciting.
Can you zoom in a little bit just so we can? Yeah.
All right, then I'll tilt down a little bit.
I'm about to say yeah. Is it?
How's
That's
that?
perfect.
See it now?
Mm-hmm.
Perfect. So you can see the result there. Okay.
Right there.
All right, here we go. Not supposed to do it this way, y'all, but I'm doing this for you. You ready?
Holy cow.
Did you see the steam coming off of that?
Yeah.
You see all the heat?
Mm-hmm.
This is a pretty serious chemical reaction right now. But what we're producing is water vapor and oxygen. We are breaking off that little bit of water. Let me see if I turn this on, if you'll be able to see the water vapor a little bit better. Can you see the steam coming off of there?
Yeah.
Yes.
If I touch this bottle, I'm fairly certain it's going to be hot. Oh, yeah, it's very hot. Burn my hand. I'm going to try to move that quickly over to here.
Because of how fast it reacts compared to the other experiments, is it
Yes.
like? Is it kind of pointless to add the food color into this one?
Exactly. What did I leave out of this particular experiment, friends? I left out the soap, which gives us a much more visible reaction, and I left out the food coloring, which also makes it easier for our eyes to see. I've got a safety glove on now. Set this over here. All right, I think I'm going to go a little bit wider, only so you can see this reaction. I'm going to use a little different bottle. Use this one. Now, what is unique about this bottle shape?
Is it a flower base?
Flower vase, but it has a super long neck. Okay, super long neck, and because that neck is super long, it's going to control it's going to direct the energy coming out upward. So it's going to go up the neck. Hopefully, it's not going to go all over the place. Now, right now, I've added some potassium iodide to my container here, and I'm going to put my lid on. I'm going to shake it up. I want that potassium iodide to dissolve completely. Set that there for right now. And I'm going to add my hydrogen peroxide, my H2O2. I'm assuming my vase has been cleaned. Doesn't take very much of this stuff. I want to be able to do another experiment, so I'm going to hold this back. What color should I add? I need a helper. Somebody give me a suggestion.
Purple.
Purple. Oh, by the way, guys, I forgot to tell you from the earlier experiment, lemon juice, lime juice will also work with the baking soda. I meant to point that out to you. So if you grab you can grab little versions of these as well. Pretty cheap. All right, I'm gonna add the other two ingredients we're missing. I'm gonna add a purple. Oh, come on, let's make it purple. How's that? Better? It wasn't being skimp. I didn't skimp on that one. And then I'm going to add, what's the other thing I need to add?
The potassium stuff.
Potassium iodide. But if I do that right now, what's going to happen?
Chemical reaction will happen.
Exactly. It's going to come flying out of there, and it's going to go. It's going to splatter everywhere. I want to control the reaction a little bit better.
Dish
So
soap.
some of this, the Ninja fluid, also known as what? Yes, dishwasher. Thank you. Exactly. All right, everybody see that clearly?
Yep.
Potassium. All right, you know, I wish I had another person here so they could switch cameras, but I'll tell you what I'm going to do. I'm going to get risky here. I'm going to move my keyboard closer to me so that I can go wide right after I pour this in. What do you think? I just don't want, okay, this is making me nervous. I count down from 5. Ready? Go. 5.
5, 4, 3,
3,
2,
1.
2,
2. 5.
4, 3, 2, 1.
1.
Whoa!
Wow.
Oh my gosh.
That was so exciting.
Fast. That was so fast.
Wow. I got a bucket of foam.
Yeah.
And this bucket of foam is pretty much just soap filled with oxygen released. I can take a bath in this. I'm not going to take a bath in this. Do I want to touch it?
No.
I don't want to.
Yeah.
If I touch it, it could potentially burn me. I don't want to get burned.
Oh.
Is it hot?
All the oxygen's leaving. We should do this experiment again. That was cool. We should do it again, shouldn't we?
Yes.
Yes.
Let's change our configuration on this. We're going to put in a lot less. We'll put in a lot less potassium iodide. I think we'll
Yes.
let's try this. And this time we'll go ahead and use the
That was big.
water bottle. Ooh, that's hot. That's pretty hot. All right.
Do you have to clean that out?
Open the foam. I just want you to be able to see what's happening.
I think he had a question, Professor.
Yes.
Quinn had a question.
Do you have to clean that out?
All right.
Say that again, Twin. I don't think he heard you.
Yeah, I didn't hear it.
I said, do you have to clean the tools out to do it again?
Yeah, you mean, well, after we're done, I have to clean. Yes, you cannot. Oh, I see what you mean. I thought you were talking about chores. Yes, here's the reason. With hydrogen peroxide or potassium iodide, they want to react. Anytime they're around each other, they want to react. Anything left over in those bottles is going to react or it's going to interact. I don't even think I can use those other bottles for the experiment again because even the ones that I use the baking soda in or the vinegar will have an effect on how good the experiment works. So the cleaner the bottle, the better. All right, so there's my water. What am I going to add to the water? Yes, potassium iodide, exactly. That's what we were going to say. All right, potassium iodide this time. And did you notice what kind of bottle I'm using here?
What?
What's this bottle made of?
Plastic.
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 The other bottles were made of
Glass.
Glass.
glass. And in fact, a couple of these are actually made of a crystal glass called borosilicate glass. It actually takes a lot higher temperatures to create borosilicate glass. We know that sand can be melted into glass, but the stuff you see glass blowers generally work with is actually low heat. It's a low heat reaction. Borosilicate glass is sand that takes a much higher temperature to melt, which is good. That way we can do chemical experiments without melting or breaking glass everywhere. So try not to do these high-end experiments in anything that isn't super thick glass or high-quality glass. All right, so I'm going to add my hydrogen peroxide. I said I was going to do a little less, right?
Carbon dioxide.
A little less hydrogen peroxide. And let's see, what color can we do this time? Can I go green? Did we do green yet?
Yes, green.
Let's go green.
That's what Twin been waiting on.
Face boogers.
Can we?
Right.
I got a question.
Yes, sir.
Can we mix the coloring, food coloring?
Sure. Yeah, you can mix food coloring because food coloring is generally derived from something that won't interact. It's actually considered, because we eat food coloring, it's generally not anything that's acidic or terribly basic or alkaline. So it's relatively neutral, like water. In fact, most food colorings are made with a water base and then derived from something that is neutral. A good example of that would be bug wings. Most red comes from a certain type of beetle. And we can eat beetles, and beetles are protein rich and taste great. So, right?
Yeah.
Anybody here like beetles?
Huh?
You guys eat beetles?
No.
Well, we might be eating beetles in the future. That's the science experiment I'm working on. Come here.
Ugh.
We can eat cricket. We can make cricket cookies. Crickets.
Ugh.
High protein. You can eat a cookie that's, instead of being all sugar and carbohydrates, it can be a high protein cookie that tastes like a regular chocolate chip cookie, but actually doesn't have a lot less sugar.
I step on a cricket but not eat it.
Oh, don't step on a cricket.
It's our
I kill them.
but I feel bad for them. All right, here we go. Green. I think this is going to be better. Let's see what happens. Are y'all ready?
Mm-hmm.
Just get it out of the way and stop all the drama.
That's cool. That one went slower.
Much slower.
Faster. Oh my God.
You know why it's doing that, right, guys? What did I change or leave out in this reaction?
Baking soda?
I didn't put in the
Carbon dioxide.
I didn't
The
put
dishwasher.
Salt.
it in, right? There's a reason why I did it this way, and I'll show you in just a second. Can you see the smoke?
Yeah.
Whoa, that bottle fell over. It can't take anymore.
That was a big one.
It fell over because the
It
base,
have no more oxygen.
and it didn't have anything in it to keep it down, so it lost its mass. Are you noticing anything else weird about this bottle? I don't have a comparative bottle. You'll have to take my word for it, guys. That bottle is shrunk. It's much smaller now. When we heated the plastic, it actually shrunk the bottle.
Yeah.
Yeah, you all believe me, right? All right. I think I need to do it one more time. Let me see if I can find one more.
Yeah.
Ooh,
Yeah.
Friends, check it out.
Is that a bottle?
That's a bottle. That is an old school apothecary bottle. I don't know what came in it originally. I would assume it's just styled after an old style apothecary bottle. Okay, we're gonna do this one more time.
Yes.
All right.
Let's mix the food coloring.
Okay, we'll mix the food coloring. I'm gonna go ahead and pour in the hydrogen peroxide.
Let's do.
Now, another name for hydrogen peroxide, we could call it hydrogen dioxide, but for some reason, Latin works better when you call it hydrogen peri. I don't know why. I don't know why a lot of the Greek that we've decided to use, not Latin, but the Greek we use in naming things in science are the way they are. But instead of it being hydrogen dioxide, meaning 2 oxygens, we call it hydrogen peroxide. Wait, where do we go? Colors. Well, you know what color we haven't used yet is yellow.
Orange.
Yellow,
Yellow. So,
orange.
Should
Wait,
we do orange?
orange.
All right, so I don't have any
Purple. Do purple.
yellow.
I mean
So
pink.
I put in the yellow.
Already did purple.
What
Pink.
color
Pink.
with the yellow to make it orange?
Pink. What do you mix
Red.
with yellow to make it orange?
Now it looks kind of yellow, doesn't it?
Yeah, red.
But it's, I mean, it looks kind of orange, but it's actually yellow. Here's what I'm gonna do. I'm gonna put some along
Let's
the
make a rainbow.
taste the rainbow.
Bloody.
All right, bloody. All right, get this out of the way. I need to add some agua to this. I got a whole picture of it, so I'm just gonna do that. Now I work with another guy. His name is Hazmat. Hazmat always gets on me because he says I'm not exacting enough. And he's absolutely right. There is a perfect mix for potassium iodide and hydrogen peroxide. But I get pretty close. What else do I need to add now?
Peroxide dioxide.
Oh, not yet. What do I need now?
This soap.
This time we want to watch it foam a little bit better instead of just get hot and explode. I'm going to put lots of it in here. And I'm actually going to pull this back because I have a feeling I'm going to make a mess on the floor. It's just a feeling. I'm going to move some things off the table. Again, this is all just precaution.
It's gonna get everywhere.
We don't want to. All right, get rid of this.
Everywhere.
All right. Feeling good?
Yeah.
Looking good. All right, here we go. There's the shrunken bottle going away. Oh. All right, get all my dishes out of the way. Everything that has to be washed. I love all the colors, though. You got the red here and the green and red. It's quite lovely. This is still ugly. Hold on. Am I taking too long?
No, take your time.
You are such a patient crew. Thank you very much for being so patient while I fastidiously clean up after myself. Here we go. All right. I'm going to turn the fan off so I don't blow foam everywhere. Be right back. It's really hot in our lab here. Our studio lab. By the way, guys, just to brag a little bit, Mr. Bond and his son, this is actually a shed that we used. This was our storage space for all of our materials. And we moved all the materials into our office space. And Mr. Bond and his son, over 2 weeks, I helped a little bit. I actually am more responsible for the lighting and getting everything done technologically. But they came out here and they made this entire studio. Put up the walls, put on the ceiling, set it all up and decorate it. Pretty cool, right?
That's cool.
Yep.
Here we go. Count down. 3,
2,
2, 1.
It won't spell. Ah!
Whoa.
Wow.
Wait.
Alive!
Still going. It's going slow motion. Wow.
Still going.
It's making a rainbow.
Didn't shoot quite as high as I'd hoped.
It's making a flag.
All right. So that's all I have for you today. But I also want to remind you of some things. If you want to look around on our website, we are actually doing live library shows all over Tennessee, Kentucky, Alabama, Mississippi, Georgia. And you can actually, if you look on our website, MrBondtheScienceGuys.com, you can actually
We put it in the chat.
doing these or check our Facebook page. And you can log on to those sites for free. On their Zoom, they'll give you the links. And you can actually watch us do completely different experiments that we're doing. We're doing experiments based on Imagine Science. Well, it's actually called Imagine Adventure, I think, or something like that. That's the theme of the library. You can come watch those for free. Also, we do have some science camps going for the summer. We have we have some of our old school companies that we work with doing live programs, but we can do live. We're doing a live camp online as well. If you go to MrBondtheScienceGuy.com, you can check into that. I'm having trouble speaking today. Can you tell I've had a long weekend? And you're the first people I've probably talked to over that long weekend. If you want to unmute yourself, if you have any questions, everyone's behaving so well, but if you have any questions as I clean up, I would be happy to answer some questions. Otherwise, I'll just shut things down and you all can get on with your day.
Thank you for coming.
Anybody have questions? Woo! Smells like the gym.
Anybody got any questions for Professor Graybeard?
I just said thank you for coming.
Oh.
He said, thank you for coming.
Thank you very much. I appreciate your appreciation. I'm very happy to be able to do this with you all.
Yeah,
Yeah, this
so
is
much.
awesome.
Yeah, I'm grateful for Mr. Bond and grateful that we've had the opportunity to come up with some ideas. To be honest with you, I've been asking for this for a long time to be able to actually do some virtual stuff. Because I think this serves a larger community. And I'm hoping the much larger community around the country as well. Science Guys of Baltimore work with us now. They've come down here and they're actually working with us as well. Mr. Bond's family, actually. But hopefully we can continue to serve you both live and local and possibly through the interwebs.
Yeah,
So-
for sure. Thank you so much. And I wanted to point out that we record our enrichment sessions. So we recorded this session and we're gonna upload it onto our YouTube channel so we can put on our website if you don't mind.
I have no problems with that. Thank you so much.
Cool. We'll make sure to tag you in whatever we post. Thank you. Everybody clap it up for Professor and give him a thank you.
Thank you. Thanks for being such a great audience. I hope you had fun.
Oh, we did.
Oh, we did.
Awesome
Have a
job,
great
Graybeard. Awesome job. Awesome job.
Heading off. Bye, guys.
Bye.
Bye.
All right,
Bye.
y'all. That was awesome. Y'all enjoy it?
Yep.
Oh yeah, y'all see how like everything he used, majority of the stuff for like the minor experiments.
My laptop's about to die and I can't see my charger. I think I'm gonna have to exit
Yeah, we about
and
to.
come
I just
back.
want to point out that if you want to do some of that stuff at home, I wrote down the basic one. All you need is baking soda, vinegar, and dishwashing liquid and food color.
So if I exit out, that means my laptop dies.
Oh, it's okay. We about to head out. Does anybody have any questions about today? Tomorrow is the t-shirt making contest. You're also gonna need
Put the
crayons, your canvas, Does anybody have a hot glue gun at home? I know it's kind of
No.
They sell hot glue guns at Family Dollar. Does anybody think their parent can run and go get a hot glue gun by tomorrow? Like
Yep.
$5 at the Family Dollar
Yeah, I
For
think.
what?
for
Or
a hot glue gun.
I know. What is
And a
it?
hair, does everybody have a hair dryer?
Yes.
Yes.
Okay. So yeah, I will email your parents. Just remember tomorrow you need your t-shirt, your
What T-shirt?
Ariana and Neek and twins and MJ, I should be able to get your Lydia, you have yours. Rihanna, your mom may be coming today. I should be able to get a lot of people their stuff by tomorrow. Okay.
Okay.
All right. Anybody got any questions?
No.
All right, well, I'll see y'all tomorrow. T-shirt making contest and
Thing in a chat.
yeah. Y'all have a good one.
Miss
Bye.
Ashley,
Yeah. Any questions? I'm sorry. Go ahead, twin.
will you put the Instagram in the chat?
Oh yeah, let me put the Instagram in the chat so y'all can go follow us. So for when y'all do projects at home and y'all want to share them. Here we go. You got it, twin?
I'm getting it.
Okay. Well, Alex, Lydia, y'all got anything else?
Nope. No.
All right, well, I'll see y'all tomorrow. I'm gonna let twin write down this. If y'all want to follow us on Instagram, I just put the Instagram name in the chat.
Bye, Miss Ashley.
Bye, Alex. Have a good one, buddy. Twin, let me know when you're finished.